In this video, I have a differential equation y times 1 plus x squared times y prime minus x times 1 plus y squared equals to 0. First of all, I want to find a general solution of this differential equation, and then I will use the given initial condition to find a particular solution for the general solution. So let's get started. So first of all, since this is using separation of variables, so let's try to have all the x on one side and then all the y on the other side. I see a 0 and I see a minus x times something. So first of all, let's put the minus x to the other side. So the first line is y times 1 plus x squared, and then y prime equals to x times 1 plus y squared. And then I have a 1 plus x squared in parentheses. Let's put that to the right hand side. So I have y times y prime. Maybe we can do this. Y times y prime equals to x times 1 plus y squared divided by 1 plus x squared. And then I have a 1 plus y in parentheses. So let's divide that quantity on both sides. And then we have y divided by 1 plus y squared. Let's push the y prime out. So the y prime, I'm going to put that as a dy dx. And then x divided by 1 plus x squared. Okay, so now I have all the y on the left side or the x on the other side. And then what we will have to do is we will have to multiply both sides by dx because we want to move this dx to the right hand side. Okay, so we have y divided by 1 plus y prime, and then dy equals to x divided by 1 plus x squared dx. So now the separation of variable is done. So let me make a note for you. From line 2 to line 3, 4, 5, this is separation of variable. So this is separation of variables. So now I have all the y on the left and all the x on the right, and then the next step is we have to perform an integration. So my students, they like color coding a lot, so I will just do the integration in a different color. So I have dy on the left, dx on the right. I will just integrate both sides, and then oh, by the way, in the integrand that is supposed to be a y square, right? So let's put the square back. And then now we continue the integration. So this is a typical U substitution problem. We are going to let U equals to 1 plus y squared. So du is equals to 2y dy. And then 1 divided by 2y du equals to dy. And then for the change of variable, we will replace this dy with 1 over 2y du. And then for the x, all you have to do is you let u equals to 1 plus x squared. So it's basically the same thing, except the variable is different. So let's go ahead and do that. So the y will be cancelled, right? So we have integral 1 over 2, and then 1 divided by u squared. So 1 divided by u du, and then on the other side, that is 1/2, 1 divided by u du as well. And then that is ln, right? So let's do the ln. So we have 1/2 ln absolute value of u equals to 1/2 ln absolute value of u plus c. So usually I stick the plus c to the x side, and then the u is 1 plus y squared and 1 plus x squared. So we put that back. So since 1 plus y squared is always positive, then we don't need the absolute value anymore. So 1 plus y squared, and then this is 1/2 absolute value, not absolute value, parenthesis 1 plus x squared, and then you add a c to it. And then the next step in differential equation is you have to know how to manipulate the c. But before we do any manipulation for the c, we have 1/2 on each side. So I want to get rid of the fraction by doing a multiplication. We multiply both sides by 2. So after multiplying both sides by 2, we have ln 1 plus y squared equals to ln 1 plus x squared, and then plus 2c. All right, plus 2c. And in differential equation, this is something that you will have to know. You have to figure out another way to write a 2c. So the 2c, so here I will just let the 2c equals to c. Why? Because a constant is just a constant. So a constant is just a constant doesn't matter how you express it. So does not matter how you express it or write it. And then I continue 1 plus y squared that is equals to 1 ln, so ln, and then 1 plus x squared, and then you add the 2c to it. So the 2c is just a c, right? And then I want to do one more thing. So the c, I want to combine the c with the ln x, and then, so here is another magic. I will just let c equals to ln c. Another line. So ln 1 plus y squared that is equals to ln 1 plus x squared, and then plus ln c, and then use the sum rule of ln. So the sum rule is if you have ln a plus ln b, that is equals to ln a times b. You study that in intermediate algebra and pre-calculus. So this is called the sum rule for ln. So we have ln 1 plus y squared equals to ln 1 plus x squared, and then just multiply the c right next to it. And then we have another rule. So if you have ln a equals to ln b, that means a is equals to b. This is a 1-to-1 property of ln. So therefore, we have 1 plus y squared equals to 1 plus x squared c. All right. So let's just move this over here, shall we? Let's just move this over here. So the answer is 1 plus y squared equals to 1 plus x squared, and then times c. So this one, you don't need to move the 1 to the other side. You can leave the 1 plus y squared on the left-hand side, and then I will just call this my general solution. So this one, I will just call this general solution. And then to find the particular solution, you have to plug in the initial condition to it. So this one, let me just copy and paste. So I'm going to copy, and then I'm going to go up and then paste to this little box, or maybe outside, so I have more space for myself. So this is the general solution. The initial condition, the book usually they put it in this way: y of 0 is equals to square root of 3. That means when x is equals to 0, y is equals to square root of 3. And then all you have to do is plug in, so 1 plus square root of 3 square, and then that is equals to 1 plus 0 square times c, and then you have to solve for c. So this is 1 plus 3 equals to c, and then c is equals to 4, and then at the end of the day, 1 plus y square, that is equals to 4 times 1 plus x square. So this is my particular solution. So let's label that this is my particular solution. And then that is the end of this problem. So if you think my instruction is helpful and clear and straightforward, share the video for me, give me a like, subscribe to my channel if you're on your way out. I will catch you all in the next lesson.